Hello everyone, and welcome to part 3 of the Az-204 Study Cram. If you missed the chance to watch the previous recordings, make sure to do so before continuing with this one. So let's get into it. Starting off with the Microsoft Identity Platform overview. So what do we mean when we say Identity Platform? Identity Platform is a service that's responsible for issuing tokens to users and applications. With Microsoft, just as we have Platform as a Service, Infrastructure as a Service, there's also what is known as Identity as a Service, which is a service that's, again, responsible for giving tokens to users and applications. Now, what do we mean by a token? Tokens are base64 URL encoded strings that contain information inside it, and it's typically access level information. So if I show you a very quick example on this screen, we can see this token contains information inside it, such as the name. Typically, this contains some access level information, for example, like files.read, files.write, etc. So when we say tokens, typically inside those tokens, we have access level information embedded inside them, and we typically provide those tokens as means to prove that we actually do have the access level. And if I want to show you a quick relevant example on this diagram, which is how you interact with the Azure portal, typically you have a user that is signing into the Azure portal, providing credentials to the Azure Active Directory. In this case, it's the Identity Platform. And if the credentials are correct, the Identity Platform will then give back an access token to the Azure portal, and then the Azure portal will use this access token to access the Azure resources. In this case, it's trying to read from a storage account. And if I actually want to show an example on the Azure portal, if I click on this alerts resource, my Azure portal is accessing the Azure alerts resource, and I would expect a token to be attached with the request that is getting or fetching those alerts information. And if I actually click on this API call, I can see there's a bearer token attached with the request headers. And inside that bearer token, there's access level information that the backend is reading to confirm that the portal, in this case, has relevant permissions to access the Azure resources, in this case, fetching the Azure alerts. And as I mentioned, all of those are known as authorization flows. Now, obviously, this diagram is very much simplified, but what we see here are known as authorization flows, and we have many different types of authorization flows depending on the client that has been used. For example, if it's a single page application, there's a specific authorization flow. If it is a native application like a desktop application or a mobile application, there's also a specific flow used there. And if it's a backend application, there's also a specific flow as well. And if I go to the documentation and I go under the authentication protocols, under OAuth 2.0, which I will explain more about in a bit, I can, for example, see there are many different kinds of flows, and those depend, again, on the type of client used. In this example, there's the OAuth 2.0 client credentials grant. And as you can see here, this type of grant is commonly used for server-to-server interactions that run in the background. In other words, this is where there's no immediate interaction with a user. And this is relevant to the example I mentioned about the PowerShell script that just deletes emails every night. All of this uses a protocol known as OAuth 2.0. Now, there are many different explanations about OAuth 2.0, so I'm going to try to provide you the simplest explanation. OAuth 2.0 is a way to grant an application access to resources without sharing secrets. Let me explain that in a diagram. So in the old days, without OAuth 2.0, let's say you built a very cool startup application called Automatic Twitter Tweeter that basically tweets on behalf of users. Now, in the old days, you can have the user simply share his username and password with your application, and then your application would simply use the user's credentials to post tweets on his behalf. Now, obviously, this is not ideal because we don't want users to be sharing their usernames and passwords with our applications to be able to access the Twitter API. And this is why OAuth 2.0 was actually invented, and it is a way to access those Twitter APIs without having the user sharing his username and password with our application. And the way this works is we would register this application on the Twitter identity platform, and then we would have the user logging in with his Twitter credentials, in this case, essentially interacting with the Twitter identity platform. So the Twitter identity platform will check the user's credentials, and if they are correct, it will give back an access token to my application, and then my application would use the token to post tweets on behalf of the user himself, rather than use the user's credentials. And I don't want you to be confused here, because you can see that the user still logs in and still types his username and password, but essentially that interaction here is actually just with the Twitter platform. It's not with my application. So those credentials are actually only shared with the Twitter identity platform, and obviously they have to be shared because the Twitter identity platform still has to authenticate the user. So this is how this whole thing with OAuth 2.0 started. It was just a simple way for applications to gain access to third-party APIs like Facebook, Google, Twitter, etc., without having the user share his credentials with the application. And before I go further with this, I want to kind of distinguish between authentication and authorization. So authentication is the process that identifies the user, and authorization is the process that checks what permission that identified user has to a specific service. Okay. Now, what I've shown you here, this is actually an access token used for authorization purposes, because we are using that token to access the Twitter APIs. But on top of OAuth 2.0, something known as OpenID Connect was built on top of it. And OpenID Connect actually gives you back an ID token, which is used for authentication purposes. So for example, when you log into Facebook right now, you will actually get back both an ID token and an access token. The ID token is actually used to identify you, to know who you are actually, and show you all the relevant profile information that's specific to you because you logged in. But with the ID token, there's also an access token, and that access token is used, for example, to access your friends lists, posts or images, etc. And going back to my slide, the output from an OAuth 2.0 flow is an access token, and OpenID was built on top of OAuth 2.0, and the output of it is an identity token, sometimes called ID token. Now, the question is, why is all of that important to our own internal applications? Now, the reason why this is important, and the reason why having an identity provider is super important, is apart from just giving the convenience to users of having them log into an application using their third-party providers like Facebook, Twitter, etc., which actually provides a much nicer user experience because they can already use those credentials and they don't have to keep on remembering different usernames and passwords. I think the more important reason is you have essentially outsourced authentication and authorization to third-party providers. Now, you can certainly, by all means, in your own application, store the usernames and password in a database and authenticate those users by checking whether the credentials provided match those that are in the database. But this is a lot of heavy lifting for you. So why not outsource this procedure to third-party providers and essentially just have users simply log in using their Microsoft accounts or Google accounts or Facebook accounts without you having to deal with the process of storing secrets in your database and then having to deal with all that security overhead. So this is why it's important to use identity providers for our own internal applications, both for user experience, second for ease of management, and third for security, because those big companies have all the large infrastructure and security measures implemented in place, and we want to take advantage of those. Let me now perform a quick demo. And before I perform this demo, I want to quickly explain this diagram. So with this diagram, I have an application hosted on a web server, and that application exposes payment APIs and orders APIs. And we want to make sure that we protect those APIs, meaning that only clients with the relevant token can access those APIs. So no one from the outside world can just randomly call those APIs without providing a relevant token. Now, there are many different ways of protecting an API. For example, you could use things like subscription keys, etc. But in this case, we want to integrate our application with an identity provider, in this case, Azure AD, in order for clients to be able to present us tokens before accessing our APIs. Now, the way this works on a very high level is we would first need to register the payment and order APIs on Azure AD app registration. So that's the first step. The second step is we need to expose the APIs inside the application registration. I will show you more about that in a bit. The third step is to register the client application on Azure AD with the relevant redirect URI. Again, I'll dive deeper into that in a bit. And the last step is to add API permissions to the APIs exposed in step 2. Now, before I go to the Azure portal, I want to show you the sample code that I have. And as you can see, I have a very simple Node.js application, and I'm protecting this precious /hello API with a bearer token. Now, as you can see here, there's some code that you probably maybe don't understand. This is using Passport library, but essentially with any programming language, you will most probably end up using libraries to perform such functionalities. So in this case, I'm protecting this hello API with a token, meaning that only clients who present a relevant token will be able to access this APIs, and I can actually prove it right now. So if I go to Postman and I try to access this API, I will actually get an unauthorized message no matter how many times I try. Now, unless I provide the right token to this API, otherwise it will not work. It will keep on giving me unauthorized. So let me now follow the steps I have outlined in the diagram I explained. And what I will demonstrate is actually Azure AD B2C. Now, the experience is very similar with Azure AD, between Azure AD and Azure AD B2C. The simplest way I like to think of the difference between Azure AD B2C and Azure AD is that Azure AD is typically meant for collaboration or for businesses or for internal employees. Azure AD B2C is typically for your consumers, typically for your own external clients. Now, when you're building applications, probably if it's a public applications, you want users to be signing up to your applications, public users. And this is typically where Azure AD B2C is used, more for consumers of your application. Now, following the steps I have outlined in the diagram, the first step is to always register the web APIs on Azure AD B2C or Azure AD. Again, the experience is very, very similar. Now, in this case, I have already done that, but if you go to new registration, you can just give a name for this Azure AD registration, and then you would choose those relevant settings that's relevant to you. So if I want to show you the one that I have already created, I would register this application, and I've just arbitrarily called it Web API-1. And the first thing I have to do is to always expose an API from this backend. Okay, so I'm exposing API from this backend. In this case, the API I am exposing is called hello, because this is the API I'm actually exposing. I'm just giving it the name hello with the scope name of hello. But typically here you would have things, for example, like files, files.read, for example. This is like a relevant scope name, but in my case, I just called it hello just for simplicity purposes. But the point is you always have to expose an API here, and this will make more sense in a bit. So that's the first step. The second step is we have to register the client application that's actually going to use our API. So if I go back, I've already registered this SPA front end, and I've given it a relevant redirect URI. So if I go to overview and I go to redirect URIs, I can see I've given it this redirect URI, which is essentially the home page. And you typically have to give redirect URIs to your client applications, and redirect URIs are basically URIs that you are redirected to after you successfully authenticate. Again, this will make more sense in a bit. Now, what you need to do with this client application is you need to access the APIs that you exposed in the previous step. So in this case, what you can do is you can click add a permission, and then you can actually choose APIs that your organization uses, or you can do one that you created yourself. In this case, I've created those two APIs, but this is the one that I created in the previous step and that I exposed. So this is important because, and as you can see, I'm allowing permission on this hello API. And again, it is a delegated permission because the user is going to prompt that flow. Now, if I want to show you the client application really quickly, it's a very simple React application. If I click sign in right now, and actually before I do that, I'm going to open the browser tab. And if I click sign in, let me provide the credentials. So in this case, By the way, I've already done the work of just registering this user on Azure AD B2C, but you can always sign up, obviously. I just did this in advance to save time. So if I click sign in, okay, bunch of stuff are going to happen. Now, supposedly, my client application, in this case, this browser application, should have gotten a token and should be using this token to call my protected API, the one that I was not able to call previously and here on Postman. Okay, so this is still going to give me unauthorized. Now, if I click call API, and if I actually delve deep into this one, I can see, first of all, that I'm attaching this token. By the way, this is a success because if I click on preview, I can see this is giving me thanks for accessing my hello API, which is the message I actually want to return. And if I actually copy this token that the client application has used, and if I go back to Postman, and if I go back to authorization, I chose bearer token in this case. And if I just paste that, and if I send this now, this should work. As you can see, it is working and it's giving me back the relevant message. And if I actually tamper with this token, by any chance, this will not work. Okay, it has to be the exact same token that I used. As you can see, it's giving me back unauthorized. So with this, I have essentially protected my backend API. And now only clients with the relevant token and those that are registered on the identity provider can access my API. So essentially, I have locked in my API access and no one can access them except those who can provide the relevant token. Next, I want to quickly touch on shared access signatures or SAS tokens. And SAS tokens are tokens that provide granular access to Azure services. And examples of services are Service Bus, Event Hub, Storage Account, etc. So let's take Storage Account as an example. Let's say you have an application that's trying to access a storage account. You can obviously give that application the storage account key, but you don't need to give that application this key because with this key, the application can essentially do anything with that storage account. It can delete the storage account. It can read anything. The access is there for a long period of time. So it's not a very granular access. So that's why we rely on services like SAS tokens, which essentially provide granular access to Azure services. And if I show an example on the Azure portal, under security plus networking with shared access signature, you can choose the allowed services and then you choose the allowed resource types. In this case, I want my application to access containers inside that storage account. And then you would set a start date and an end date. And then after that, you would generate that SAS token. Now, my application will use this SAS token to access containers in that storage account rather than giving it the storage access key, which essentially the application can do anything with. The next section in this exam is about Azure Key Vaults. Now, a vault in general is a service that allows you to store secrets, keys, and certificates. Now, secrets from the name are just secrets. Those can be passwords, connection strings, or any other secrets that you store in your a part of your configuration in your code. Keys are essentially used for cryptography. It can be a public key or a private key. And lastly, there are certificates. And certificates are essentially encrypted public keys signed by a certificate authority. So usually certificates are used whenever you want to prove the identity of your application. Now, what is the benefit of using a service like Azure Key Vault or any centralized vault service? Now, the first reason is centralized, meaning that many applications can share this centralized vault rather than have each and every single application deal with their own secrets separately. So we can have a centralized store of secrets, keys, and certificates where many applications can access this store. The second benefit is that it's secure and it is protected by Azure AD RBAC, meaning that you can enforce strict permissions and access control policies on the actual vault itself. A next benefit of having a centralized service like Azure Key Vault is that you can easily monitor access and use. Maybe for audit purposes, you want to monitor how many times a secret is being accessed. This is done very easily using Azure Key Vault. And lastly, there's simplified administration with things like rotation. Now, whenever you are dealing with secrets, keys, etc., you typically want to rotate those keys or secrets. And with Azure Key Vault, this is made so much simpler where you essentially don't have to make any changes to your application code. And I will talk more about that in a bit. And if I quickly demo that in the portal, this is an example of an Azure Key Vault resource. And as you can see under settings, we have keys, secrets, and certificates. So if I go to the secrets section, I can choose to generate one manually. You can generate one from your own application code. In this case, you give it a name and value. This example is a key value pair. Actually, secrets are always a key value pair. In this case, I have a name of test-secret2, and I can click on that. I've previously created this just to save time. And notice that we have this secret value, and I can show that secret value. And accessing this secret value is done by this specific URL. Now, you might wonder, okay, what if someone gets a hold of this URL? Does that mean that he can essentially access this secret value stored in Key Vault? And the answer is no. That's why there is an authentication layer to Key Vault. Having this URL does not necessarily mean that you will get access to this secret value. That's why there's an authentication layer. And with the authentication layer, there's typically two options. The first and the simplest option is using Azure Key Vault Managed Identity, which I will talk about in a bit. But with Managed Identity, essentially only your authorized applications are able to access this specific URL and authenticate with Key Vault. The other option is, without relying with Managed Identity, is to essentially just register your application on Azure Active Directory. You let your application retrieve a token, and then it would use that token to access this URL and then get back a secret value. So my point behind all of this is that there's an authentication layer behind Key Vault, and not anyone with this URL can access this secret. And if I want to go back to some other options, here under monitoring, you can set several alerts, metrics, diagnostic settings for audit purposes. I want to show you something quickly actually related to versioning. So right here, when I click on new version, I can provide a new secret for this name. So basically, the nice thing about this is that if I change the secret value, or create a new version for this secret, I don't have to update my application code. My application code will simply use this URL, and this URL by default will point to the latest version. So this is a very nice thing from Azure Key Vault, because you don't essentially have to make changes to your application code whenever you have new secrets or new versions of this secret. Now let's talk about interacting with secrets in your own application code. I will show this example using Node.js, but this is applicable to any other framework or language. Essentially, the steps are the same. You would have to import an identity credential, whether that's the default Azure credentials or a managed identity credential. And then you would import the secret client object from the Key Vault library. And then after that, you would essentially define this credential, because you will use managed identity in this case, and then we would create the Key Vault client using the secret client object, passing in the relevant credentials. And then after that, we would use the client.getSecret method to access this secret. Now, what about app configuration, which is actually a very small part of the exam? So Azure App Configuration is essentially a configuration store where you can store configuration files in a centralized place. Now, in your application code, you would typically have several configuration files. For example, in .NET Core, you would have the app settings.json. In Node.js, you would have several other configuration files where you can store things like, let's say, connection strings and other configuration information. So with Azure App Configuration, instead of storing that configuration in your own code, you would store it in a centralized place on Azure App Configuration. Now, this is best used with Azure Key Vault because there's native integration between them. So let's say you are storing connection strings in your configuration files on Azure App Configuration. Instead of storing the value of the connection string on Azure App Configuration, you would simply store a pointer to Key Vault, which actually contains the connection string, essentially keeping your secrets on Key Vault and just configuration-specific information on app configuration. Now, Azure App Configuration stores data as key value pairs, and I will show that in a bit. If I go to this app configuration resource and under operations, I go to Configuration Explorer, I can see a bunch of key value pairs that I've already imported as part of my configuration file. And the way to import it is by going to this tab, and then you could choose the source service. In this case, it could be another app configuration service or from Azure App Services, or just a configuration file that you import. And I've already done this in advance, and this pre-populated all of those key value pairs. Now, the important benefit of using a service like Azure App Configuration is you essentially store your configuration in a centralized location. Again, many applications can leverage this centralized configuration file rather than managing different configuration across different applications. So this is a big benefit, in addition to things like auditing, same benefits as we discussed in Azure Key Vault, as well as security as well. Now, another neat benefit to that is you can rely on things like feature flags, which are essentially ways to make changes to your application without redeploying it. So let's say you are testing out if the green button is actually generating some traffic and you want to change this green button to red button. You can use feature flags to change this inside the configuration file. Because it is stored externally from your application code, you don't have to redeploy the code to see those changes and turn this button from green to red. So this is a very neat feature, and this is known as feature flags. And the way to interact with app configuration using code is you would define the app config from the app configuration library, and then you would define a connection string. In this example, we'd use a connection string to authenticate to Azure App Configuration, and then we would define the client, and then after that, we would simply get the configuration settings from our application code and use it in our application logic. Next, I will talk about managed identities. And before I talk about managed identities, I want to explain a world without managed identities. Now, a world without managed identities is where we essentially rely on connection strings, secrets, and SAS tokens. For example, let's say we have a web application that is accessing a storage account using SAS tokens. Now, the way for this web application to authenticate to a storage account means that it has to use secrets like connection strings or SAS tokens in this example. So it still has to rely on some form of a secret to authenticate to storage account. Example 2 is, for example, when a web application is accessing a storage account using service principal, meaning that the web application itself is registered on Azure Active Directory, and then the application would use the client secret to get back a token from Azure Active Directory, and then would use that token to access the storage account. In example 2, you are still using a secret, which is the client secret on Azure Active Directory. So you still have to manage secrets even in the second example. And bottom line from both of those examples is, a world without managed identities is a world where you would have to rely on secrets to authenticate to Azure services. Now, a world with managed identities is essentially a world where an application authenticates to an Azure resource without relying on secrets. This is the beauty of using managed identities. Now, the more technical definition is that a managed identity is essentially a managed service principal assigned to a specific resource like Azure VM. So when you enable managed identity on a specific Azure resource, behind the scenes, it actually registers a service principal that is automatically managed by Azure, meaning that it deals with things like client secret rotation and all of that. So you don't have to worry about the actual service principal, rather than have you manually register the application on Azure Active Directory. Now, the steps to enable managed identities are, the first thing is you would create a managed identity on an Azure service like VM, for example, and then you would assign that identity read permissions on an Azure storage account, for example, and then inside that VM itself, you would call a specific URL to get back a token without relying on secrets whatsoever. As you can see, this is the special URL that is used here on this screen. Inside the VM, if I call this specific URL, I will actually get back a token from the storage account because I enabled managed identity on this specific VM. And lastly, the VM would then use the token to access a storage account. So essentially with managed identities, I have successfully configured the VM to access a storage account without relying on secrets like SAS tokens, storage account keys, etc. And with managed identities, we have two types of managed identities. The first type is system assigned, and this is a one-to-one relationship between the identity and the resource, and its lifecycle is dependent on the resource, meaning that you assign this managed identity to a specific Azure resource, and if you delete this Azure resource, then the system assigned managed identity will also be deleted. So it is a one-to-one relationship between the identity and the resource. This is known as system assigned. The second is user assigned, and this is a one-to-many relationship where you can assign that same identity to multiple resources. Let me give you an example. So Say that you have multiple VMs behind a load balancer and you want those VMs to access a storage account. Okay. Now you can by all means assign system managed identities or system assigned managed identities on each specific VM, or you can simply create a user assigned managed identity and then use this user assigned managed identity to apply it to all of the VMs. So it's essentially a one-to-many relationships rather than manually creating a system assigned managed identity for all of those VMs to access the storage account.